Hi guys, I decided to make a video because I just didn't want to have to type up a storm. And often when I type up a storm, people don't get what I'm talking about and I try to visualize it. So today we're going to talk about observational science and looking at the sun and looking at the shadows and where should the sun be. One of the most compelling arguments that Flatopians have is that the sun is 3,000 miles above us and 30 miles in diameter. And the reason that they chose those specific numbers is that it kind of makes sense on their Flatopian map as to how high up in the skies the sun should be at high noon, and how big it appears to be. And this is the second part. That's the angular size. And that's how much basically the sun takes up of the horizon. The horizon being 360 degrees around you. And if it was to be placed over the horizon at its widest point, how many degrees would that sun take up? And there's a number online and you can find it. And that number corresponds to 30 miles wide and 3,000 miles away, and it also corresponds to whatever the size of the sun is that is accepted by science, and 93 million miles away. So either way, it has the same angular size in the sky. And that's kind of important because in this particular one here, you can see that I have the what I call Earth sun's path and Flatopia sun's path. Oops, sorry, I didn't get that right there. See that there. Okay. So the flat earthers would want us to believe that where this line is, so first of all, just to understand it, so the sun rises here, goes across the sky, and sets there. Now, if it were just 3,000 miles up, it would change in apparent size. But disregarding the fact that it doesn't change in apparent size, what they say is that this, if you draw a line across here, is where the actual horizon is. And that's why it looks like that. But the problem is that this arc here doesn't quite look like that. That's a little bit more stretched out in elliptical. Now, some people say, hey, look, you drew it that way. That's not the way it is. Here's what I then challenge you to do. Get AutoCAD or any other program and just start making a design proportionally. You don't have to put 93 million miles or 3,000 miles. You just make it the same ratio. You could make it 3,000 inches, etc. And then only 30 inches across. Either way, whatever you decide to do, if you do it in an actual drawing and you make it scale factor, you're going to see that when it's 3,000 miles up and only less than 6,000 miles away, because let's say you're in, I don't know, New York, how far away would the sun be from you at midnight? It would be about there in the horizon. It wouldn't touch the bottom. Okay? Try it with any kind of three-dimensional math. And the other thing, of course, is that the sun doesn't change in apparent size. So getting back to what I was talking about earlier, as you can see, the sun would be, I don't know, maybe a third of its size by the time it was over there, apparent size in there to there. I think so. If you do the math, that's how much it should shrink. And we know how much stuff shrinks because we've done the math. We've done the geometry, and you can do it yourself. Take a picture with your camera and have it fixed on a tripod, and stick that tripod, stick an object, I don't know, a known size object 10 feet away, and then bring it 20 feet away, and then see how big it appears in the pictures, in the two pictures. And, don't change any of the settings, just click and then click again, and you have the background to match it up with, and you can make sure that there's no, funky stuff going on. Anyway, long story short, it will appear to be about roughly half the size. And this here would shrink as it goes. So at high noon, it would be really big, and then you should be able to do that. And you should be able to also, on a flat Earth, take some kind of an angular size gauge and be able to look at the sun and know exactly what time it is. Exactly. All you'd have to do is put yourself into the ground positioning system. That's a funny one. Yes, because GPS doesn't work in the ocean. Anyway, you could just have to put in your location, and then it would tell you how big the sun would have to appear to be, and then it would look at the actual size of the sun, and you would know exactly what time it was. I know it's a funny way of doing things, but you should be able to do that on Flatopia. You can't. So, by apparent, observational science, I mean, we look at the size of and the path that it takes of the sun just by how it appears in the sky. But you can also look at it from another point of view. All right. On March 31st and September 21st, on the actual equator, the sun rises directly in the east and sets directly in the west, and it goes right over your head. So on either the globe Earth or Flatopia Earth, at noon we all agree that the sun is directly over you. So this is you, the little X there, and there's where you are. Okay, so the sun rises here, the sun sets there. Sun rises here, the sun sets there. It's going around in a circle in Flatopia. Now, here's the thing. That's east, and that's west. I'm sorry I didn't write that down for you before doing that. In Flatopia, okay, you would be looking towards the east and a bit towards the north. So the sun would rise in the northeast, zip across over you, and would set in the southwest. But that's not what happens. Observational science, in other words, look at what you see, shows us that the sun goes like that, directly overhead. It always follows this one line. They can show it on that, and the way you can see it with a shadow is they have a pole, and that pole either casts a shadow this way in the morning until high noon. It doesn't cast any shadow, and I experienced that in Costa Rica in April, and then it does the same thing going in the other way. So when the sun is setting in the afternoon, the shadow gets longer and longer and longer, pointing directly east. In Flatopia, that sun, that shadow would start here, like that, and then would magically appear on the other side like that, going like that. That doesn't happen anywhere. March 21st, September 21st, or wherever the solar equator is, okay, it doesn't matter then, you just find out wherever the sun is passing directly over you on planet Earth, okay, or Flatopian Earth, have a look. This never happens, cannot happen on flat Earth. It can't. It's an impossibility, yet it happens. Flat Earthians cannot understand that. You look in one direction. I'm not talking about compass headings or magnetic or whatever. I'm just talking look in one direction. The sun would rise, go directly over you, and set. That's what happens. We've observed that. We experienced that. I experienced that personally. That can't happen here because you're always going to be looking at one way, then one direction, then one direction, then one direction. So there you have it. Two simple, observational science. This is what they like to use in the Flatopian arguments. You know, I believe what I see. It's flat. You know, water seeks its level. Another crap like that. Anyway, there you have it. You have two very simple things that flat earthers cannot explain. And it's not proving globe Earth, it's disproving flat Earth, which then proves globe Earth, because the only way this can happen is on a globe Earth.